Good afternoon, students. Today we are going to see the rocket propulsion, how the rocket is propelled, how it is pushed up. We have seen a lot of satellites being launched. You see the rockets moving up. So what are the principle it depends on, based on? Two principle. One is principle of conservation of linear momentum and the other one is Newton's third law. You can refer the book Principle of Conservation of Linear Momentum. There is no change in the linear momentum of a system of bodies as long as no net external force acts on them. A moving body, if it is not acted upon by any external force, it will keep on moving. Their momentum will be conserved. The second one is Newton's third law. For every action, there is equal and opposite reaction. If you take this is a rocket, the rocket is filled with the fuel, maybe liquid or solid fuel, hydrogen, liquid oxygen, etc. These fuels are filled in this one, and when it is fired, what happens? This fuel burns and then they eject a hot gas downward. Hot gas is pushed downwards. Now this gas that is coming out, hot gas that is burnt and coming down, is giving a thrust or a push downward or a force acting towards downwards. So Newton's third law states that for every action there is equal and opposite reaction. Now because of this opposite reaction, the rocket starts moving up. As it starts moving up, the law of conservation of linear momentum acts. That means there is no external force acting on them. The rocket is gradually moving up. And as they move up, the fuel also reduces, fuel குறைய ஆரம்பிக்கும். So there is also velocity also increases because the weight of the rocket decreases. There is a thrust towards downward. The rocket keeps on moving. Since there is no any external force, the momentum is conserved. At one particular point, it reaches a velocity where no more gravity pull is acting on the rocket due to gravity. There is a force due to gravity. So no more gravitational pull at particular height. What happens? At this velocity, it escapes into space and moves in the orbit. The rocket moves in the orbit. So that is to say, this velocity is called escape velocity. Escape velocity. This is how the rocket is propelled up. Next one is gravitation. Newton's universal law of gravitation. This law states that, you can follow the book, page number 8, that every particle of matter in this universe attracts every other particle with a force. This force is directly proportional to the product of their masses and inversely proportional to the square of the distance between the centers of these masses. The direction of force acts along the line joining the masses. Now, this is called Newton's universal law of gravitation. According to Newton, every body attracts every other body. So this is the law of it can be small object, it can be big, it can be as big as Earth, as big as Sun, etc. So this is the law of the universe where every body attracts every other body. Now, the law, according to this law, the force is directly, let us take for example two objects, two bodies. One is mass m1 and the other one is slightly smaller one, m2. Now these two are attracted. This is attracting with a force F1. This is attracting with a force F2. Now the distance between their centers is r meter. Now according to Newton's law, the net force is directly proportional to the product of their masses, multiplication of their masses m1 and m2, and inversely proportional to the square of their distance between them, their centers, that is r square. Directly proportional, force is directly proportional to product of the mass. Directly pros means mass increases, force increases. If the distance increases, force decreases. That means according to this inversely proportional, when the distance decreases, force increases because this the denominator isn't it. இந்த வேல்யூ அதிகமாச்சுன்னா இது குறையும், இது குறைஞ்சதுன்னா இது அதிகமாகும். So therefore this is inversely proportional. Now combining these two equations, let us write F is proportional to m1 m2, m1 into m2 divided by r square. Now you have to remove this proportionality. When you want to remove the proportionality, you have to, when you put equals to sign, you have to add a constant. You put this constant as g. G is the proportionality constant, is called, this g is a proportionality constant. So this g is called universal gravitational constant. Universal gravitational constant. Now this g, unit of this g is Newton meter square per kilogram square. Newton meter square, that is not this. If you want to convert g, keep g this side and take force this side, r square, cross multiply r square divided by m1 into m2. Therefore the unit will be Newton meter square per kilogram square, because force is measured in Newton, r is meter square, mass, that is kilogram into kilogram, kilogram square. Since is the denominator, you bring it up, it becomes kilogram per kilogram square. So this is the unit of gravitational, universal gravitational constant. Now this value found out in SI system, it has been found out value to be 6.674 into 10 to the power minus 11, 10 to the power minus 11 Newton meter square per kilogram square.
Acceleration due to gravity. It is represented by the letter G. What is acceleration due to gravity? Suppose a ball is thrown upward. You're throwing a ball, throwing it up. What happens? It falls down. Okay. When the ball falls down, it gains momentum or acceleration. The velocity keeps on increasing when it falls down. So it has been found out that for every second 9.8 meter per second, that is to say second square. So 19.8 meter per second square. Now for every second it increases by 9.8. So 1 second 9.8, next second 9.8 plus 9.8, third second 9.8 plus 9.8. Like that it keeps on increasing. This is called acceleration due to gravity and it is represented by the letter G.
Now we are going to see relationship between G and G. What is that capital letter G? This G is universal gravitational constant. Universal gravitational constant. Now what is this G? This is acceleration due to gravity. In the previous video you would have seen this. So what is the relationship between these two? Now every object attracts every other object. Now let us take, this is the earth, and on the earth there is a small object is standing. Now we are able to stand because of the gravitational pull. This is the center of the earth, center of the object, and this is the distance between these two. Let us take mv, the mass of the earth, and mv, the mass of the object, a small object. Now it has been calculated, radius of the earth r, that is this distance r, is equal to 6,378 kilometer, approximately 6,400 kilometers. If you travel downwards into the earth, you will reach the center of the earth. So therefore this gravitational, universal gravitational constant G Now we can calculate what is the relationship between two ways. First one is the force acting on this mass, that is G m divided by r square. This we have seen already. Okay, when two body attracts each other, the product of their mass is directly proportional and inversely proportional. The force of attraction inversely proportional to the distance between their centers, square of the distance between their centers. This is one equation. Now according to Newton's, now we can, this distance from the center of the object to the earth, now this distance here is very negligible amount. Say for example you have a football. Can you compare the radius of a football and the radius of the earth? So it is, that is radius of a football maybe for example just 15 centimeter radius. If you compare this one 6000, what is it? So it is negligible. So therefore we take r square. Now force, according to Newton's second law, force is equal to mass into acceleration. Mass into acceleration. Now between these two, this acceleration is due to gravity. This A can be changed as mg, acceleration due to gravity, equation 2. I am substituting this here. Force is equal to mg, that is equal to g m divided by r square. Now I keep g only this side, acceleration due to gravity, cross multiply g m divided by r square. This you bring it to denominator, cross multiply. This m and m will get cancelled. Therefore g is equal to universal gravitational constant into mass of the earth divided by r square. So this is how we come to the derivation of the relationship between this g and g, that is g universal gravitational constant and this g is acceleration due to gravity. Now we can calculate the mass of the earth from this equation. Mass of the earth, பூமியினுடைய mass எவ்வளோ, you can calculate from this equation. That is, keep m is the mass of the earth. M is equal to, keep this one, take r over g is there already, r square on top, cross multiply and bring down this g. Now we know the values of all this. Okay, we are not substituting here, and it has been found out to be, we know the radius of the earth, we know acceleration due to gravity, and we know universal gravitational constant, that is 6.674 into 10 to the power minus 11. I substitute all this one and then you will find out the value to be 5.972 into 10 to the power 24 kilogram. That means 5, suppose you take this 9, this decimal that side, 972, already 3 zeros will move out, therefore out of 24 zeros you add up to 21 zeros, keep on adding, so many billion kilogram, right? So this is the mass of the earth. Next one is variation of acceleration due to gravity. Now the gravitational force varies from place to place, from distance to distance. For example, earth is not supposed to be considered as perfect spherical. பூமி வந்து perfectா spherical கிடையாது, slightly flattened on top, right? Slightly flattened on top. That is what it has been proved. So the earth is not exactly spherical, slightly oval in shape, right? So therefore from the center, the radius of the earth, this is the equator and this is polar region, pole, பூமியினுடைய pole, north pole, south pole. It has been found out the distance between from the center of the earth to the equatorial region is 6,378 kilometer, whereas from the center of the earth to the north pole or south pole is 6,357 kilometers. So there is slight variation is there, 78, 57. So therefore, the radius value changes. We know that if the r value increases, the inversely proportional gravity decreases. When r value decreases, this value increases. Therefore, the gravitational pull at the polar region will be greater than the gravitational g value at the equator. At the equator is less compared to the pull of gravity in the equator. That means to say, if you are standing in the equator, the gravity pull will be slightly less compared to if you are standing, if the object is placed in the polar region where the gravity pull will be slightly greater. Similarly, as you go up higher, the gravity pull, the gravitational value decreases. Similarly, if you go down deep into the earth, the gravity value, acceleration due to gravity, decreases. And if you reach the center of the earth, the g value will be equal to 0. There won't be any gravity.